बाइनोमियल डिस्ट्रीब्यूशन के बाद नाउ लेट अस टॉक अबाउट बर्नौली डिस्ट्रीब्यूशन. Let us consider a single trial the trial can result on two possible outcomes that can be labeled as a success or the failure. The trial results of two possible outcome labeled as सक्सेस और फेलियर. दो पॉसिबिलिटीज़ हो सकती हैं किसी ट्रायल में, इधर सक्सेस, और सक्सेस को हम रिप्रेजेंट करते हैं P से प्रोबेबिलिटी ऑफ सक्सेस, और फेलियर को, सक्सेस और फेलियर दोनों म्यूचुअली एक्सक्लूसिव आउटकम्स हैं, तो इनकी प्रोबेबिलिटी हम लिख सकते हैं probability of success as P. Now the probability of failure would be 1 minus P. Then random variable X has Bernoulli distribution as distribution as x of k, p of k into 1 minus k. या इसको हम लिख सकते हैं p of k is equal to p raised power k 1 minus p raised power 1 minus k. For k is equal to 0, दो पॉसिबिलिटी, k की वैल्यू 0 हो सकती है या 1 हो सकती है. When k is equal to 1, then the probability of success would be p of 1 minus p raised power 1 minus 1 would be 0, so you will get the probability of success. या probability mass function जो है that is p. So for as k is equal to 0, then the probability, it will give you the probability of failure. So the probability of failure is 1 minus p. So in this case the mean value would be mean value or expected value, that is a mu, that would be equal to p, and the variance is p into 1 minus p. प्रोबेबिलिटी मैस फंक्शन जो होगा इस केस में सो प्रोबेबिलिटी मास फंक्शन को हम पी ऑफ एक्स ऑफ के लिख सकते हैं एज k is equal to 1. Its probability of success is suppose p, then the probability of failure would be when k is equal to 0, it would be 1 minus p. So this is the probability mass function. So from probability mass function we can find the CDF. CDF would be like this. For k is equal to 0, here k is equal to, when k is equal to 0, the probability of failure, we represent CDF as capital F of x. So it is 1 minus p. So when k is equal to 1, the CDF would be like this. This is p. Now let's solve an example for Bernoulli trial, Bernoulli distribution. Suppose approximately one in 200 American adults are lawyers. So out of 200, one American is a lawyer. One American adult is randomly selected. What is the distribution of number of lawyers? We have to find the distribution of number of lawyers. So the probability of liar, because there is only one liar out of 200 American, that would be 1 by 200. So this is the, and its complement, the probability of failure would be 1 minus 1 over 200, that is equal to 199 divided by 200. Now p of x is equal to p raised power k 1 minus k. So p of k would be equal to 1 over 200 raised power k into 1 minus 1 over 200 raised power 1 minus k. For k is equal to 0 or 1, p, when k is equal to 1, x is equal to 1, we will get the probability of success, that is 1 over 200. So in case of failure, x is equal to 0, that is when we incorporate k is equal to 0, this will vanish, it would be equal to 1. So 1 minus 1 over 200 is equal to, so this would be 1 minus 0. So इस एक्सप्रेशन की जो है पावर 1 होगी. सो इट इज़ इक्वल टू 199 डिवाइडेड बाय 200. Next, let us solve few problems related to binomial distribution. As we know, the distribution of number of successes in an independent Bernoulli trial is the uh, binomial distribution. So let us solve a few problems. Those are related to binomial distribution. So first consider uh, okay, let's solve a problem. Uh, Consider a binary source generate generates digits uh, 1 and 0. Randomly with probabilities as 0.6, we have a binary source that generate digits 0 and 1 randomly with probabilities as zero point 0.6 and zero point 0.4 respectively. The digit 0 has a probability 0.4, whereas the digit 1 has a probability 0.6. Now we have to find uh, what is the probability that two ones and three zeros occur in 5-digit sequence. In B part, what is the probability that at least three ones will occur in a 5-digit sequence. Now, taking into account the first part, we already know the probability of occurring a 1 is 0.6, whereas probability of 0 is 0.4. So in first part, we have to find the probability that at least, that the two ones and three zeros occur in 5-digit sequence. So in first part, let X denote a random variable of ones generated in a 5-digit sequence. So let us suppose X is a random variable of ones generated in 5-digit sequence. 5-digit sequence में जो है जो वंस जनरेट हो रहे हैं उसको हम रैंडम वेरिएबल x से रिप्रेजेंट कर रहे हैं एंड वी नो स्टेटमेंट में क्या था ओनली 2 पॉसिबल आउटकम्स 0 या 1 है 5 डिजिट्स में तो हमने जो प्रोबेबिलिटी फाइंड करनी है दैट द प्रोबेबिलिटी दैट 2 वंस जो है 5 पॉसिबल आउटकम्स में अकर करें सो इसके जो पैरामीटर्स होंगे दैट इज़ p is equal to 0.6 the probability of occurring 1 is 0.6 and total number of digits in a sequence those are 5 and k is equal to that shows the number of ones that is equal to 2 so it clearly show that the random variable is a binomial the variable x is x is a binomial रैंडम वेरिएबल सो इसका जो सोल्यूशन होगा प्रोबेबिलिटी ऑफ x इज इक्वल टू 2 विच इज़ यह हम कह सकते हैं x इज इक्वल टू k एन चूज k p रेज पावर k 1 माइनस p रेज पावर n माइनस k so x is equal to 2 so n is equal to 5 in this case and k is 2 5 choose 2 into the probability for success was 0.6 that is already given in this question so and the value of k is 2 so 1 minus p is equal to 0.4 and this would be equal to 3 so after solving this problem we will get the probability 0.23 in the b part we have to find what is the probability that at least 3 ones will occur in 5-digit sequence now at least 3 ones will occur so there could be a 4 or 5 ones so we have to find the probability that at least 3 ones should occur so uh, so in B part we have to find at least 3 ones will occur in 5-digit sequence so इसकी probability क्या होगी रैंडम वेरिएबल x शुड बी ग्रेटर आर इक्वल टू 3 तो हम इसको लिख सकते हैं टोटल प्रोबेबिलिटी जो है दैट इज़ इक्वल टू 1 उसमें से हम सब्ट्रैक्ट कर दें व्हेन x द प्रोबेबिलिटी रैंडम वेरिएबल x is less than or equal to 2 so so first let us find the probability that x is less than or equal to 2 this would be equal to summation k is equal to 0 to 2 5 choose k, 0.6 raise power k, and 0.4 raise power n minus k. So we have given here n is equal to 5, where k is from 0 to 2. So after solving this, I will get the probability that x is less than or equal to 2, that is 0.37. So by incorporating this value, the value for this probability in this equation, we will get the probability that ones will occur at least 3, that is equal to 1 minus 0.37, that is equal to 0.684. So the probability that ones will occur at least 3 times in 5-digit sequence is above 68%, we can say. So next, let's solve another example. A fair coin is flipped 10 times. Flip 10 times. Find the probability of occurrence of 5 or 6 head. We have to find the probability that occurrence of 5 or 6 head. So we have to find the probability that the head will occur 5 or 6 times, and the coin is tossed 10 times. Now suppose x is a random variable showing the number of heads when a fair coin is flipped 10 times. With its इसके पैरामीटर्स क्या होंगे? विद इट्स पैरामीटर्स, टोटल जो है 10 टाइम हमने कॉइन को फ्लिप किया है, सो n इज इक्वल टू 10. द प्रोबेबिलिटी हेड की क्या हो सकती है? बिकॉज इट इज़ अ फेयर कॉइन, सो इट वुड बी 1/2. सो नेक्स्ट वी हैव टू फाइंड the probability of head that head will occur 5 or 6 times. So the probability that x is greater than 5 and less than or equal to 6, greater or equal to 5 or less than or equal to 6. So it would be summation k is equal to 5 to 6. 10 choose k, 1/2, because the probability is 1/2, raise power k, 1/2 n minus k. So by solving this, we will get the probability that head will occur 5 or 6 times, that is equal to 0.451. Next, let us solve another example. Consider the experiment of tossing a coin. Head appears about once out of every 3 tosses. So in every 3 tosses, when a coin is tossed, in every 3 tosses, the head appear once out of every 3 tosses. So if the experiment is repeated, we have to find what is the probability that head appears exactly twice during first 5 tosses. Now the number of tosses in this question is 5, and we have to find the head appear exactly twice. So first consider the experiment of tossing a coin. The head appear about once out of every 3 tosses. So the probability of head would be 1/3. So suppose x is a random variable that shows the number of heads okay, with parameter इसके क्या हैं? The parameters are probability is equal to 1/3. So the number of tosses were n is equal to 5, or the head should appear exactly twice. So the k would be equal to 2. So incorporating this in binomial distribution, so I will get p of x is equal to 2. This would be equal to 5 choose 2, और probability कितनी थी? 1/3 थी. 1/3 रेज पावर k 2 के इक्वल है. 1 minus 1/3 and minus k would be equal to 3. So this is 5 factorial divided by 2 factorial, and minus k would be 3 factorial, be equal to 1/9, and this would be equal to 2/3 raised power 3. After solving this, we will get the probability that exactly 2 head will occur in 5 tosses is equal to 0.329. Next, we will discuss the Poisson distribution in next lecture. Thank you.